So we're down to this stuff. Might as well. So we did the first bit of chapter 4 last time, which is searching through an application, and we got a few more things to say about it. So we talked last time a bit about automated spidering. So it automatically clicks every link and tries to find every page. You can also have users do the user-directed spidering, which you did in the first project where you used Burp. You just surf through a website, and it just records everywhere you go. So it doesn't try to find things, it just remembers what you do. And therefore, if you click every link and fill in the forms and go to the pages and log in and all that jazz, then it will record what you did, and that's, of course, a good way to do it, although it requires a human to do some of the work. Chrome developer tools, you've used, I think, already in this class. Very nice. You can see exactly what is sent by your browser and exactly what comes back by your browser. One good thing about it is it doesn't matter whether it's encrypted or not, because the browser knows, and it shows you what I sent and what I received without the encryption. You don't need a proxy, and it also shows you the timing. So you can, if you load Hackazon, which is the fake Amazon you're playing with, it'll load this page and then load a bunch of CSS and then load JavaScript and load all these images. So there's many, many requests. And it'll show you every request. If you click on it, you'll see the raw request and the raw response. And over here, it shows you the timeline, which is very important to developers because I don't know if it's true anymore, but it certainly was true 10 years ago. People had limited bandwidth, like 56K, and you would make a page and it would take too long to load. It was a real common problem. So you would really want to know, why is it taking so long? And often you'd add like one more little widget or something to the page, and that would turn out to come from some server that didn't work very well, and that one thing would be making your page slow. And the point of this is you can very easily spot which one thing is taking too long and then change that or take it off. And so yeah, here's another timeline where it just shows you the time it took for all these different things to load and color codes them and everything. It's a productive tool for developers. It's also useful for us as attackers, but its primary purpose is to help developers make better web pages. So there is hidden content on web pages. I find it a lot. It's always there. This is a perennial problem. People put stuff on a web server that they don't want you to see. This is like another bizarre thing. People put stuff on Facebook that they hope people won't see, which is kind of pointless and self-contradictory, but they do. And there's stuff on their web server that they don't want people to see. This keeps on happening. At the very least, the earlier versions of things are on the web server, the backups, and the prototypes of the upcoming versions are often on the web server. Those things logically should be somewhere else, and certainly anything confidential should be somewhere else, but people often just get used to assuming that anything you put on the web server will not be found if they don't put a link to it somewhere. Another thing that happens, by the way, is people install automatic upload features like WebDAV, where you store something in a folder on your machine and it automatically synchronizes with the web server. So everything you do is ending up on the web server and you don't know it. Another place this happens a lot is GitHub. People write code and then somebody starts putting it all on GitHub and they put secrets in the source code and stuff, and they don't realize that everything you do is actually being published to the world. So anyway, so there's files up there that are not trivially linked to, but they can be found. Google is very good at finding them, of course. That's what they do, is find all the files on the internet. So if you put up something, you just give it a funny name and don't link to it, you'll very likely find it in Google next week. They have debugging, different categories of users, backup copies of files. All these things are probably on your server. And one thing fun about backup files is they might have a different file extension or not have execute permission, so they won't run. And that means if the viewer browses to them, they will see the raw source code. Now, this is another big issue. Developers like to believe that the viewer cannot see the source code. If they write like a PHP script, all you see is the output of the PHP script. But if you actually saw the source code, that would reveal their secrets. They often put plain text and important comments and stuff, AWS keys, passwords, everything in the source code, assuming people can't see the source code. And there are a series of mistakes that happen that cause people to see the source code. The most obvious one these days is when they just put it on GitHub. But there's a bunch of other cases in which web server gets confused and serves up the source code. So you really should not be putting secrets in the source code. Another case is the one I'll show you later, an Android app. Most Android developers do not appear to realize that every Android app gives you the source code. It's not like compiled C code at all. You can totally see the source code in every Android app. And there are obfuscation tools that do absolutely nothing, that make people think they've removed that stuff when they haven't. So there's configuration files, there's source files from which stuff was compiled, there's comments, and there's often log files on the server. There are often deliberate web apps so people can remotely view the log files, so they can debug server problems. One big one is LMA. I came across this a few years ago in a Troy Hunt article. LMA is used to publish web server log files on Windows systems, and Toyota used it. I think I mentioned this before. And it stores every error, just appears in the log file, and the log file is publicly visible to everyone. So all you have to do is send someone a malformed link to Toyota with like an apostrophe URL. If they click on it, their authentication cookie will be in the log file, visible to the whole world. This often happens. Anyway, this sort of thing happens. So if you want to find all the things, you can try brute forcing. If you want to be mathematical, your picky people might say brute forcing is where you actually try every possible combination of letters. But in practice, people call it brute forcing when you do a dictionary attack. You have a dictionary of common names and you just try them all. So you might find login, forgot password, and these things, and then you might just try everything like that. Just try a long list of common words, and it'll just try all of them and see what's out there. And this is essentially what Google does to find things. Burp has a brute forcer that will do this automatically, but the free version is limited to be super slow, so it's useless, like 1 guess per second or something stupid like that. You don't even need it. It's very easy to just write your own Python brute forcer. This didn't take long to write. Python is very easy. You can just have a list. You can go get a list, common word list, and just try them one by one. There are other tools out there. Google wrote one called Skipfish that will do this for you, which tries their list, which is really quite good. So, but I was able to try 1,800 guesses in 50 seconds. So if Python is fast enough to do it, and that's essentially what Burp would do if you paid for the pay version, I imagine, although I haven't paid for the pay version. So I got a few hoots about that, and then we'll try a few other things here. What tool shows you the timing of the components? All right, Chrome Developer Tools. What tool is ineffective in the free version? All right, Burp's brute forcer. The spider is okay, but the brute forcer is crippled. All right, what tool shows you HTTPS as easily as HTTP? All right, that's Chrome Developer Tools. Burp, it's not as easy. It's a man-in-the-middle attack, and you have to import the certificate or you'll get errors. It will try to stop you from seeing HTTPS traffic. So how do you find all the content? Right, there's no sure way, except of course a way that is not discussed in your book, which is find a vulnerability, take over the server, get root on the server, and then you can actually list all the files on the server. But there's nothing in the way of web requests that will find it all. So it's an approximate process. You try to find stuff. I got KC, Emmanuel, and Jeffrey A. Way, and off we go. All right, so you can look for patterns. So if you see forgot password, you can then try add password, reset password, retrieve password, and all that jazz once you get an idea of how they think. I remember some years ago when I was just beginning at this, somebody said, I want you to test my website. So I went there and the main page was login 2. And I said, well, I wonder what login was. And login 1 was the earlier version of login where you could totally log in as administrator with no password and take everything over. And in like 10 minutes, I had their whole site. Said, what happened? I'm like, well, it's not rocket science. So look for numbers or dates. Check the HTML and JavaScript files. We were at the Hackers Club. They were talking about hackthisbox.eu, which I logged up. It's very nice, especially if you want to get the OSCP certification, and you have to hack the page to get in. What you have to do is look at the source code and then load all the JavaScript and read it and figure out how to get in. So it's kind of fun. The comments may include names of files or query strings, and you may find stuff in the other components like Java applets and ActiveX controls if they have that old stuff still. And these may all point you to objects that are not directly linked. You can look for temporary files. Here's a file that's created by Mac. Windows has a thing to have images. It creates in every folder, and Mac creates this thing, so they're automatically generated files that list everything. If you edit a file, it makes a backup file here with PHP editors. A lot of tools like Microsoft Office makes temp files all the time, and they often get stuck there. So these are other things you might find. Burp Pro has a thing called Content Discovery that will try brute force and try to take the names and then modify them, extrapolate what it can find, try different extensions, spider from anything it finds, look for more links inside it, and so on. These the intelligent things it will do, and there are other tools that will do it. Skipfish is the one I like. Google advertised this as a vulnerability scanner, and I think some people said it wasn't that good at finding vulnerabilities, but what it really is good at is finding content, because it's obviously based on Google's Spider that they use to index the internet. So this thing really tries a nice list and finds all kinds of things. It's free, a little bit flaky, but it runs all right on Kali. I've used it. Kind of nice. I think it's an alternative to that paid Burp tool. Dirbuster is another thing that was intended just for this purpose and was included in Kali. It seems to have been an abandoned project, so I don't think it's being updated, but the tool still exists in earlier versions. Now it seems to be included in Z-Attack Proxy, which you are using some of the projects. That seems to be the new tool that has caught the interest of the developers at OWASP. This is, of course, a perennial problem with open source tools. Somebody writes a tool, and after a while they get bored and wander off, and very often nobody else takes over, and the tool just sort of sits there and does not get updated until it's no longer very useful. Of course, you can go to search engines that somebody else's Spider has already found stuff, or they indexed it back in the past when somebody was actually using that and linking to it. So you've got search engines and the cached pages, like at Google. You've got the Wayback Machine that does not index the whole internet, but it indexes a lot of pages, and it keeps many copies going back in time, so you can see the way things used to look. And you can just search for the domain name in something like Google or Dogpile, and you can find pages that mention it, and you might find developers talking about the page, referring to things that are no longer public. Advanced search is good. You can specify site name to search only within a site. I do this all the time in Google. You can also have in URL, look for things in the URL, not in the content of the page. You can look for things like login in the page. You can look for URLs that contain things like login. I've done this a lot to find insecure login pages and then warn colleges and such about it. You can look for pages that link to this page with link. You can look for pages related to this page. There are just a lot of cool things. If you go to Google Advanced Search, it's a very good skill to learn how to do searching. Some web servers will let you see directory contents. FTP servers also. If you just go to the root of a file, it will just list every file and every folder. That's nice if that happens, of course. Then it's easy to find stuff. And you may find scripts with vulnerabilities. Microsoft IIS in several versions had default tools that would let you see a directory of a page that people would forget to remove when it's. Nikto and Wikto are just the Linux and Windows version of a vuln scanner, and this is not the usual kind of vuln scanner that's looking for things like SQL injection so much as looking for specific web configuration errors like PHP myadmin pages. It just has a list of commonly insecure web page elements, and it sees if they are on there. So it basically detects if you're using one of the common platforms and leaving some page exposed to the internet, which may be available with no login or with a default credential or an easy credential, easy to guess. So this is a simple tool, easy to run, and it often tells you if there's some common configuration error on the server. So here's an example of running Nikto. It's included in Kali. So I ran Nikto on my hackathon, and here it gives you a list. It tells you about some headers that are not set. It tells you Apache is out of date. And I don't think it found anything too dramatic here. It found a wildcard entry for crossdomain.xml. These are pretty commonly seen and not that obvious, not that serious. So it didn't find anything too dramatic that I saw on Hackathon, but sometimes it'll help you find open administration pages and such. All right, then there are, of course, functional paths. This is another way to go. You might have everything at the same path, like bank.jsp, and the URL never changes. Everything is in the parameters. Transfer funds from this account to that account, this amount. So you're going to have to explore this, and your automated scanners will probably not work. You have to explore this by hand, or maybe even do your own scripting to handle that sort of thing. Because exploring it means playing with all these parameters to see where they go, not going through a tree structured directory. But you can make a map, and you need a map of the objects. You have a login page, then you have home, then you have a logout, select pay, add pay, select account, transfer funds, and you have to know all the places you go in order to find vulnerabilities. You have to first map it out, like you would map out Zork, and then consider what errors might happen here, where I can jump from here right to here. Perhaps I might be able to skip the login and go straight to here and pay money without logging in, or I might be able to jump from one area to another, trick it, into doing something I shouldn't be allowed to do. Another thing you can do is add things like debug to the request in a parameter, because people often do that. There's a parameter that will cause it to go to debug mode, and that would be awesome if you can find it, because then it will show you source code or hidden things. Burp Intruder will try doing that. So you have to map the application. You have to find, there's core functionality that does whatever it's supposed to do, like buy products at the sales site. Then there's peripheral things, error messages, things that take you off the site, redirects. I see this everywhere. I know it's true of Salesforce. An enormous number of people have not actually updated to HTTPS. Instead, their server continues to serve HTTP and HTTPS, but they put a 302 redirect, so people that come in over HTTP are redirected to HTTPS, and this is a terrible idea because you can hijack them with a man-in-the-middle attack and prevent them from ever getting to HTTPS. But a lot of people do it because they don't understand how risky it is. And then here's the core security stuff. How does it maintain session state? How does it know who you are? How does it handle that token? Is that token predictable or somehow stealable? And things like user registration, password change, those are common areas of vulnerability. I know I saw LinkedIn got hacked, and I think Facebook got hacked. There was ways to reset the password, and there were ways to predict that password reset link that was going to be sent to you by something you could see on the page. So anybody could make a fake reset password and get in someone else's account. This kind of thing tends to happen a lot. So any place user input goes in is a place where you might be able to send in unexpected input and hack the server. The URL is one place, the query string that comes after the question mark, at the end of the URL, the data that comes in, post requests and the cookies, and anything else, forms, data coming in from Java or ActiveX and Flash, anything coming from the browser could have malicious input. And your server-side technologies, you may have dynamic pages on and interaction with databases at the other end for things like SQL injection, and email systems where you may be able to send extra emails, trick it into sending emails before you log in and things like that. All these things are options for places where you might find a vulnerability. So here's things. Every URL up to the query string marker, the parameters, the cookies, and all the headers. The user agent, the referrer, the accept, all these things could have a variety of vulnerabilities. There was a fun one in the, I think it was D-Link routers about 3 years ago. All you had to do was give it a user agent that was backdoor spelled backwards with a few numbers, and if you had a web request to the administration page with that user agent, you became the root user permanently. And I discovered after that, everyone that connects is now permanently the root user until you restore it to default settings. It's bloody awesome. It was some kind of debugging mode that they left in the production model. And that is very common, that people leave some kind of hard-coded credentials intended for testing or debugging or tech support in the final product. So RESTful URLs have what looks like folders, but they're actually parameters. So it's a thing to know when you're searching through it and trying to map it out. Unfortunately, everybody can make their own non-standard parameter format, which could drive you nuts. So this is the normal way. You have the name of the server, then you have a query with question and then a Q equals duck. That's how you make a search string. But you could put it in a semicolon instead of an apostrophe. You could use dollar signs or percents to the limiter, %3ds. You could have any weird thing you want. Your server could then untangle it, and that'll of course be non-standard when you're trying to index it, if they're using something screwy like that. User agent ought to be used just to tell it if you're using a funny browser, and it ought to show you a different version of the page. Unfortunately, people abuse it. One common trick which irritates search engines is you can have like a forum full of tech tips, and if the Googlebot comes to index the page, the user agent will be Googlebot. So you know it's Google, so you show them all this great content. So Google indexes it. Then when people come and they're not the Googlebot, you make them pay money to see it. This is a common trick. Google will get mad at you and delist you if they catch you, but this is common on the web. That's why you'll often search for something, find the page you want, when you go there it wants money. That's how they do it. So all you have to do is change your user agent to the Googlebot, and you'll see what they showed Google. So that's commonly a trick, but there's a lot of other things you can do, and you can also put in apostrophes and punctuation marks and do cross-site scripting in there. You often see different things with different user agents, or sometimes anyway. If you're behind a load balancer or proxy, it may use the X-forwarded for header to actually index which particular server you're talking to, because it might matter to the internal workings of the site which server you're using, whereas to the external user, the whole cluster appears to be a single server. So that's a thing to know. You might be able to use that to target one particular server in a cluster. And there's data that does not come in from the web requests. You can have email coming in, you can have like web dev things that are sending things that go up on the server that did not come from the user requests. You might have an IDS that is sniffing traffic and put it into some kind of visible log file, visible report. That was true of the college about 6 years ago. One of the first times I taught the advanced hacking class, we started just scanning the college, and all you had to do was take the IP address of the gateway, put it in a browser, and you would see the control panel for the main switches, and it would have a report of the attacks, and you could delete stuff from the logs right there without authenticating. It was bloody awesome. I told them and they took that down, but it was entertaining for a while. That was just the default configuration of our HP switches at the time. This kind of thing happens pretty often, that something that really ought to be just for the internal management people is in fact just blowing in the breeze. I found one in Texas where it was printing checks for a hospital, and it was just, you could see it printing them with no authentication at all, and you could alter them and delete them with no authentication at all. And it took me quite a while to find out how to tell anybody about it. And it turned out a Canadian company was printing checks for a Canadian hospital, but they sent it to Texas to do it, and the people in Texas could not figure out how to configure the password on the server, so they just ran it with no password at all for years. And the reason I knew about it is because I was reviewing the DEF CON talks, and there was a DEF CON talk saying, this crazy thing is often deployed with no password. It's just, and I said, is it really? And I just searched for it and I said, holy cow, it is. This intermediate thing is just used with no password all over the place. People are just asking for it. And I said, boy, George, it's true, they are. Anyway, so there's also APIs out there where you can send requests up from, say, cell phone apps, and those are often not very secure. It would seem to me, from like a management point of view, that if someone was writing a cell phone app to go at my company, I would say make the cell phone app work the same way the browser app does, but many people don't do that. They make the cell phone app come in through a different process, and they often don't bother with all the security controls for the cell phone traffic, probably because they don't want to break the existing product that's in use. So they patch something on the side that's thrown together by a different team in a hurry without the same standards. It's often the case that there are holes caused by that process.
So you're saying they go through a different tunnel
and it comes to the servers in a different way, and then they don't really have access to all the cookies and parameters they ought to have. They have some alternative functionality that is often simpler and less secure, because it's the extra thing passed on. This is where you often find the holes, is in something on the side that's not used much, like the directory of users or the reset password feature or something that's not used much. That's where something can be forgotten about and not updated to your standards. So I got some more Cahoots. If I can figure out how to get to the browser. There it is, okay. All right, which one of these is a Google product? Skipfish, yeah. This reminds me, years ago when I did Windows XP tech support, I gave a talk at Microsoft. And I had a slide like this, which one of these is a Microsoft product, and the Microsoft engineers got it wrong, and boy, were their faces red. So, all right. So, which system might put data that's sniffed in a web app? I have the Apache server status page. I mean, the IDS may detect attacks, and it just puts them in some kind of web viewable log, which therefore can be used to attack the server and stuff. You can even sometimes deface the web page by putting like a code injection that redirects stuff from the log into a file, stuff like that. All right, so which header might expose private data from one website to a different website, which is pretty rude. All right, that's the referrer. It's intended to tell you which of your ads are effective, but it does mean that you're telling this server where you came from, and if they put something sensitive in the URL, it's also going up there. All right, which phone scanner runs on Windows? All right, that's Wikto. All right. Whoa, wait. Oh, here's the winners. Okay, good. Somehow I skipped past the page, but at least I have winners, which is Matt, Patrick, M. Don't forget to tell me who you really are if you want your points. So, server-side technologies. So you go to a website like City College and you wonder, what is that thing? What is it running? Is it WordPress or what? Well, there's a lot of ways to do it. You can just look at the banner of the HTTP response, and that will often tell you stuff about the server. Apache running this version, auth pass-through running this version, SSL running that version. If the administrator has just made a default install of the web server software, it will typically tell you all this information. And this is a really bad idea. Apache has known vulnerabilities, OpenSSL has known vulnerabilities. You do not need to be telling everybody what version you're using of stuff. You ought to be updating it, but if you're not, you don't need to make it this easy for them to hack you. There are tools like HTTP Recon. Nmap will try to fingerprint things. HTTP Recon will also just try to deduce what you're using and what version by just taking responses and comparing it to a library of known fields. It looks at the little subtle differences between the way pages load from these different things. Wappalizer is a browser extension. That's what I use. I learned it in a web development class. It's very nice. Let me just show you that one. That's very easy to use. You install this extension called Wappalizer, and I think I've turned it off. I'll turn it back on. Tools, extensions, and someplace down here I have Wappalizer. There it is. So I enable Wappalizer, and now the Wappalizer site itself is using Google Analytics, JavaScript, and Swiftlet and CloudFront running on Ubuntu using PHP. That's the Wappalizer website. If you go to, say, ccsf.edu, let's see what they're using. Yes. Okay, here we are. We are using a Adobe content management system, Google Analytics, jQuery, Apache, Java, and so on. It's just fingerprints everything you go to, which is pretty cool. You can see who's using WordPress and stuff. And if you watch the news, very often WordPress has an exploit, Drupal has an exploit. So it actually is pretty important to know which product is being used, especially if people aren't keeping stuff up to date. Just knowing what product they're using can be enough to really help you hack them. All right, file extensions also make it pretty obvious. Microsoft uses ASP, that is their active server page language. So IS sites will have ASP or ASPX on it. Java will have JSP if they're using Java, ColdFusion, PHP, WebSphere, Perl, Python. Microsoft compiled code runs in DILs. And there's Lotus Domino, the three-letter extension tells you if people are using these products. Yeah, I don't know who's using Lotus anymore, but there's probably some clowns out there using it. Then you have error messages. They often tell you everything. This is the way ASP error messages look like, Microsoft extensions. I think I probably told you, I went, when Hillary Clinton was running against Obama in the primary, I went and tested the major political parties' websites. And Democratic National Committee website was okay, and the Republican National Committee was appalling. You put an apostrophe in the URL and you get pages of ASP just screaming down the page in red font. It was just amazingly fragile and fouled up, and of course running on Microsoft. And I decided not to try to warn them about it because I figured they would just lock me up or something. But a lot of the default error messages, just like the default headers, often tell you far too much information. Here's another generic error message that you'll see if you just put ASPXX, and you'll see a generic error message here if you have an unrecognized file extension, something like a 404. And your file extensions are mapped to things, and they're often mapped in IIS, in Microsoft. All these different extensions go to different DILs, different Microsoft libraries to handle them, and you might get custom error messages from each of those. So you might learn not just that you're using Microsoft servers, but you might be able to learn exactly which executable is processing them. There's another thing not mentioned here, but good clean fun, which is to mess with the method. If you look at the start of a URL, it's not showing here, but this URL is HTTP. If you want a secure site, you can go to like samsclass.info, and now that's HTTPS. There are, in fact, about a dozen other things you can put here, like Telnet, Mail2, Gopher, and there's a bunch of others. Skype had their own. These are called schemas, and there are custom schemas, and they are often very insecure. There's a whole bunch of hacking where you put something unusual up here, like Telnet or FTP, and it processes it through some old code that nobody's worrying about anymore. So you can put a malicious link on your page that when people click it, will activate the old code and do a bad thing. For a while in Android, you could just put Skype and a phone number, and if you loaded the web page, you could put it in an image tag and it would automatically dial that number with no interaction from the user. So now they're making a toll call or something, or sending an SMS without knowing it. So that's like messing with the extension. Messing with the method before the extension can also lead you into interesting little rabbit holes. All right, so here's something called BigNet that uses these crazy commas in the URL. I have seen that on the web. That's another one of these weird schemes. People make up these weird schemes and sell it, and then you can just spot it in the URL. That's got to be BigNet to have weird URLs like that. Java servlets are here. Here's Oracle servers, PLS. Cold Fusion always puts CF in everything. That's easy to spot. And Silverstream, whatever that is, I've never used it. Here's Ruby on Rails. You'll see Rails, that's really hot out there, although I don't see many pages directly with Rails in it, but it certainly is a hot development platform these days. The tokens you'll see in the cookies. To identify who you are, typically say what they are. Here's a Java token, here's an ASP token. These are your session IDs. They're just long random numbers, but they use these standard names so they expose what technology is being used. So again, PHP is obviously PHP, Cold Fusion, that's Microsoft ASP. So just looking at the name of the parameters tells you what they're using. And there's a lot of people that just use third-party libraries they purchase somewhere to do things like shopping carts and encryption and message boards and stuff, especially Android apps. They all just seem to be using about 6 libraries, all the same stuff, just patching the other stuff and making the app. So you get to where you can spot them and recognize them. And they often have known vulnerabilities. And once you find a vulnerability, it often affects a large number of apps that are all using the same vulnerable component. Here's the steps. You find every place where user input comes in, which might come in any of these forms. Then you look at the format, see if you can understand how it works, and then you know how to navigate, hunting for objects, try to map your way through, find any other source of data that goes into the app, see if you can find any side channels that are feeding data in. I know WordPress, and I think Facebook and Twitter at one time had this thing where you could send emails to post. And that was a pretty popular thing for a while. I think in the early days of portable phones, you would send emails to make Facebook posts and such, and that's another way to feed data in. Look at the banner coming back. Many apps are actually many servers connected together, so you'll want to sort of map it and see how many different servers you're talking to, because one of them may be more interesting or more vulnerable than another. Look for other identifiers. There's fingerprint tools like this. And once you get version numbers, then Google them and see if that's really the latest version or if there's a known vulnerability. And then look at your map just to see what you might find. Find out what technologies are used and what the flow of steps are to guess what abuse might be possible. HTTP print hasn't been updated too much, but Nmap does similar thing, tells you what you got. Netcraft does it online, and so does Shodan. These all fingerprint things, and like I said, Wappalizer does as well. These are all tools that will automatically figure out what version is running most of the time. So the session tokens will also tell you common technologies you can spot, and cookie names and scripts. All these things have default names. And if you really want to get in, you ought to download the software and make your local install of it and then see what happens. So by the way, one thing that was baffling in your book, I thought they were talking about babies. This is Web Application Hacker's Handbook. It uses WA for everything. Anyway, there's WA app. But here's a server-side functionality. So this thing here is Java server pages. And then you have all these parameters and the order by parameter is here. So order by is a common SQL command. Select star from users or where name equals Fred, order by date. So this strongly implies that this is just fed directly into a SQL line. So if they didn't remember to filter it, I could probably put an apostrophe there and union select stuff and get in. So yeah, this is a hint that I might get away with SQL injection. That's something you can look for there. Then there's expired content. So something here says is expired equals 0. Well, that suggests that I could change is expired equal 1 and look at expired stuff, which would be old stuff which might be valuable. You know, maybe I can look at the last guy's data, get the old cookies or something. ASPX here tells you we're using Microsoft. You have a template, which this looks like a file name and a file extension. So you might be able to do directory traversal. You might be able to put .. / and go to other files. There's something here called edit equals false. Maybe there's edit equals true, and I'll be able to modify files on the server. If I send request with edit equal true, there's a version number here. So maybe there are earlier versions of files with other numbers that I could see that might still run or contain useful information. You're just hunting through to see what you can find, like someone digging through a dump, you know. So Here I'm posting to PHP, I'm sending data here. This is an email address, and it's got the content of the email message, problem logging in, and all that. So it looks like I can put whatever I want in here. So this looks like I could use this to send emails to other people, not just to the help desk. I could send spam through their server from this. Maybe I could send email to the CEO of the company that appears to come from an internal company domain this way. And that would be great for social engineering. You know, it's realistically, this looks like something created by the help desk page, but the help desk page should not be sending the to address up from me. It should be hard-coded on the server side. Putting it here under my control is inviting abuse. View function, and so maybe you could change that view to like edit or add, to add a file or edit a file. And you might be able to change this number here. I've seen, this actually is how I get, I like to advertise when we're hiring for teachers here, but our career system, you may have noticed, is horrible. You have to go to like ccsf.edu/careers, and then you get this page you have to search for items, and it's really clumsy and hard to use. I discovered, by just experiment, that you can make a direct link to a job offer on the City College system, but they don't generate it anywhere. I just found out that you can just put a number here, and I just do a brute force search through the numbers. Every time we have another offer, I want to publicize a job, I make a page, number equals 101, 102, 103, 104, and try them until I find the one that goes to the CNIT department offer, and then I put it on my page so people can get it. It's not intended for you to be able to go directly to the page, but I get here by essentially this kind of brute forcing, playing with that parameter. I used to do this years ago. I would like play online flash games, and then my internet connection was slow, and I'd say, forget this, so I would just figure out how to download it in the local SWS file by just going through the source code until I found the direct link to it. Then I could run it locally without the internet. And there's a lot of that happens. You know, you get used to this stuff. If you figure out how the app operates, it'll probably keep doing that. They probably keep reusing code for many purposes. If you figure out how any part of it is encrypted, you can assume that the rest of it probably uses the same encryption. In fact, one good, clean, fun thing is if you find a place where you can control the data that gets encrypted for some other reason, you can often use that to break into another part. Even though you don't know the key, you can use this part to create the encrypted code to go with your, like you find some place where you put in like your username, and it creates some URL for a password reset, which has an encrypted version of your username. So you go to another place where it has a price, you can put in a price for the username, get the encrypted version, and paste it in over here to change the price, because they just reused the same code. We'll be doing that later on in the class. This tends to happen. If you find that there's a filter blocking things like SQL injection, you might be able to find other parts of the app that also use SQL that don't have the filter, because there was an insecure app, then somebody put in a defense, but they didn't really put the defense everywhere, or somebody added another feature later after the defense was supposedly in there that did not go through the expected path to pass through the defense. Kind of thing happens a lot. If the app obfuscates data, see if there's a place where it will obfuscate stuff for you. That should be an obfuscated string, and then you can play with it and see if you can deduce the scheme. And we'll do this live. I don't know if I've shown this to this class, but this is a fine example of it. This is an Android app, Stitcher, and I think this is probably a fairly modern version. When I first found this maybe 4 years ago and I notified them, they ignored it for a while. But so this thing called Stitcher does something like play music. This is an Android emulator, which is good, clean fun. This is the Stitcher app. It's actually pretty popular. But you can log in with the glorious Stitcher app. And I have sent it through Burp, and I've already imported the certificate. So it is, now Stitcher used to use HTTP with no encryption for this. And then after I complained and time passed, they actually upgraded to HTTPS. I think they're the ones I contacted. They didn't know what HTTPS was. But anyway, I humiliated, I demonstrated this at DEF CON, and I think eventually pressure got hot enough. They moved to HTTPS. So now, they no longer really have a security problem, but you can see how they work. So you can log in with other products, but you can also log in with your email address. So if I put in a@b.com, and I better have an @ I think this has to look like an email or it will be blocked. Then I put in a password of A. And say I'm done. It sends it up to the server. And here, I can zoom it up here, although I'm afraid it might not zoom up for the remote viewers. But this is checkauthentication.php. This is the request. And down here are the parameters in Burp. And you can see them here, you can see that EPX is the password and it is 2x. So a password of A becomes 2x. So let's try a password of AA. Okay, that sends a request to the server, and it's going to be check authentication. So here it is. Now it is 2x, 2x. You may be detecting a pattern. Let's try A, A, B, C, and see how that works. That's check authentication here. It is 2x, 2x, 2y, 2z. I think you can see, this is the Caesar cipher. It is just moving the letters forward in the alphabet, and when I originally tested this app like 4 years ago, this was all it did. There was no HTTPS, no other encryption. This was the encryption for your password. And this was good, clean fun. Now, they put it in addition to HTTPS. So this is stupid, but the HTTPS covers a multitude of sins, so the net result is it's not so bad anymore. It should just be using HTTPS. This is why everyone tells you don't roll your own crypto. If you make up your own crypto, the technical term is you are an idiot. You should use a standard library that geniuses have slaved up 1,000 hours to make right, like HTTPS. Then it will be good. Whatever you made up in the shower is not going to turn out to be better than HTTPS. And if you think it is, you just need to grow up and realize that mathematics has been going on since the time of Pythagoras. A bunch of really smart people have made that stuff, and whatever your smart idea is, it's not that smart. Anyway, so that's the kind of thing. You can often just put in simple test cases and figure out what they're doing. They're often doing something appalling, like just base 64ing stuff, or running it backwards, or using ROT13 or something ridiculous like. Your errors should be giving you very little information, but if you can actually cause an unexpected condition on the server so it crashes and creates an automatically generated error, that may even reveal source code, variable names, versions, and all sorts of goodies. And this is the sort of thing you'll see here. This was Walmart. I think this is real. I think I went to Walmart and I just put in a quote in the URL, and here I get all this information, which is really none of my business. Dumping down from their server. It's a Microsoft server. And it's giving me a stack trace all full of the names of routines and such, you know. Pretty rude. This is what you do in development products, so you can see the error. My test pages have PHP errors turned on. So when you get unexpected input, it shows you the source code. Now, you're not supposed to leave it on a development server. I added it deliberately so you can see it. But people that leave, this is the way it should be when you're developing it, but when you deploy it, you should turn this stuff off. So it just gives you a generic error message, but people often fail to. So your app might use a consistent framework, and then, like I say, you might have a framework which has a security update, but you want to look for something that was added later as an afterthought by some other developer that didn't go through the proper security review, like the debug function, the CAPTCHA, the usage tracking, the third-party code that connects to advertisers or something that was added on later by a different team and didn't pass through the security tests is where you'll often find the goodies. So look for client-side validation. The client JavaScript might make sure that the password is not too long, doesn't have any special characters, but it might not do that again on the server, so you might be able to grab it after the JavaScript is over in Burp, put that junk back in, and get it to go up to the server. SQL injection, of course, is the first thing you try with databases. If you have file uploads and downloads, and file names anywhere, then you can try using directory traversal to refer to other files, write to other files, read from other files. And you may be able, any place where user data that you sent appears on the page is a place where you'll see cross-site scripting. Try putting script tags in your name or whatever's appearing on the page. And if there's any kind of dynamic redirects where one page goes to another page and you can control where it goes, then you can again use that for cross-site scripting. You can even do it for content injection. You can add content from another page to the page, and that's a way to get scripts on the page which will run and attack people. If you have social networking features, you might be able to enumerate the names of the people. This happened over and over. This is what Weave did. He was able to, there are a bunch of sites, this never seems to stop, where you can just find all the users' email addresses. You can go to some page and it will tell you if that email address is a valid user or not. So you can just try a dictionary of names and users and find out who's on the site. which violates their privacy and can then be used to send them spam and phishing about that. And it also makes it easier to break into their account, because if you have the username, now you just have to guess the password, and you can just try like the top 10 passwords and somebody will be using that. If you have multi-stage logins, we'll be playing with this later, you may be able to skip some steps, like not really bother to fill in the credit card number and yet still make a purchase because you jump over that page. And your session state is a variable somewhere like a cookie number, and that might be predictable or discoverable, so you can hijack somebody else's session. You may be able to escalate horizontally from your session into some other user's session, and you may be able to vertically escalate up to administrator. Both of these could be possible. There may be clear text communications, so you can steal things from the network. Things may leak out of the app in the referrer header to other sites, and so on. These are all many things that might go wrong, so you just wander through it, just like going through a building and testing every door and every window to see if it's open. The error messages leak out information. You may be able to inject emails or commands. If you have native compiled code, like DIL files, it can now have things like buffer overflows and dangling pointers and all the exploit development sort of things that would be exploitable, and all the third-party libraries have known vulnerabilities and known attacks for them, and the same thing with the web servers. Once you know what version and what product they're using, you can just try for the common errors of that version and that product. So here's an example, I think from your book. So auth contains the authentication functions like forgot password and profile and reset password. So this is where you look to see if they handle all that correctly. Here's core site stats. This is some kind of log or usage parameters, so you might find good things in there. You might be able to, page ID is a path/home, so you might be able to point it to other things and see things you're not supposed to see, like configuration files. That works pretty often in modern JavaScript-based sites that use things like Node.js. There are configuration files you can traverse to on the server that tell you things you should not know. That's in EasyCTF. There's a whole series of a game called Toaster Wars that is in Node.js, and you keep on finding config files and getting in. It's also true of Amazon web pages and Amazon servers. They're often deployed in a way that is by default insecure. That's what Chris Vickery keeps finding, is giant Amazon buckets that are world readable. People don't know that. The default of an Amazon storage unit is to be world readable if you use their API, and people don't know that. They're trying to get enough pressure on Amazon to change the default, but it hasn't happened yet. And then there's /home there. Icons and images are more directories that point to things. Probably nothing too exciting there. Pub is where you're going to have RESTful resources under pub, like media and user one. This is obviously a user parameter, but it's treated as a file name because it's a RESTful parameter. It looks like a file name to this browser, but you can just try other numbers to try to get to other users' folders, and you might be able to get to their stuff. That was true of one of the big picture hosting sites. There's Picasa, and there's another one everybody uses, I keep forgetting the name of, where everybody puts pictures to show them to the world. And it turns out over and over again that all the pictures were in, what do you remember the name of it?
Flickr.
There's Flickr, there's another one that everybody uses, I can't remember the name of it. They have like 20 apps and they're all vulnerable as hell. And all the pictures were world readable. They had like an MD5 hash of the picture for the name, and there was no actual permissions. So people figured out how to predict the names and brute force them, and they could see all people's private pictures. Because they didn't really have authentication and permissions. They just used security through obscurity. They thought the URL was unpredictable, but it turned out it was. And here's shopping. We'll show you all the way it handles shopping. You might be able to find ways to abuse the logic there. And on it goes. You know, we'll do quite a bit of these in small test cases later, but to do a real job, you do a real full-size commercial app, you've got hours of work here just exploring every place. And there's no way to really make it exactly fun, but that's how it goes. What browser extension will tell you the web server technology? All right, that's Rapalizer. All right, what file extension will you find on a LAMP server? All right, that's PHP, Linux, Apache, MySQL, and PHP. All right, which one will you find on an Oracle server? PLS, some kind of Oracle product. Which one goes on a Microsoft server? Okay, that's ASP. Good. All right. So let me record these winners. M dot times 2, Matt times 2, and Jeffrey A times 2. Good. So if you are online and you won, you should send me a chat message so I know who you are. If you're here, you should tell me who you are. That's it. I'll just go to the lab and help anybody that wants to work on their projects.